Hi, Mr. West. I'm just retaking my video and shortening it just in case my other one was too long for you. So I have the question pulled up on my computer. I'm going to go through this quickly. I'm looking for average velocity. So my formula for average velocity is average displacement divided by time, which stems from velocity is displacement divided by time. My three givens are displacement 1, which is 20 kilometers south, 38 degrees east. My displacement 2 is 60 kilometers south, 55 degrees west. And then my final given is my time, which is 2 minutes. 2 minutes. So obviously you want to work in standard units. So this is now going to be equal to 20,000 meters. Keep my direction. This is 60,000 meters. 60,000 meters. Keep its direction. Time is now equal to 2 minutes. Minutes to seconds, you multiply by 60, so it's just 120 seconds. So we now have to break these into components because you cannot add vectors when the directions are separate. So we're going to break this quickly. Displacement 1 on the x, displacement 1 on the y. So in my other video, I do an explanation of a little trick to break it down, but we're just gonna do it quickly. 20,000. I know it's sine 38, and this is 20,000 cos 38. I want this is east, and this is south. Let's do the same thing for displacement 2. So here we are, 60,000. And then it's going to be the same thing. It's going to be sine 55. And this is going to be 60,000 cos 55. And it's west, and this is south. So because I already walked through it, I know I want to make south or west and south positive directions. So we're going to sum them up. Displacement total on the x is going to be d1x. Actually, I'm going to write it this way for you. d2x minus d1x. It's minus because it's a negative west, which is east, and you want to add them in the same direction. Then displacement total on the y, because they're both going in the same direction, it doesn't matter. d1y plus d2y. So I already have my calculations, which are on the back of the page. So I'm just going to quickly flip it. Displacement total on the x. So displacement total on the x was 36835. 36835.89315. 89315 meters west. And then displacement total on the y is going to be equal to 50174. 50174.80125. 80125 meters south. So now that we have our 2, we want to use Pythagorean theorem. I'm just going to draw out a quick example for you, which is going to look like this. This is our first vector, which is going to be dx, which is dtx, the sum. Then you want to add vectors tip to tail. So this is actually dy. I could specify that it's the totals, but obviously we know in this situation. And then here is displacement average. So on top of displacement average, we need to find the angle theta. I always like making my angle connecting to the x instead of the y. It's personal preference, doesn't really matter. So we're going to use Pythagorean theorem, which is displacement average squared is equal to dx squared plus dy squared. Isolate displacement average is the root. Dx squared plus dy squared. Okay, and we know that value was, I explained it in the other one. We went through it the long way, 62244. 62792. 62792 meters without direction. So we know tan theta, just going to use simple trig. Tan theta is the opposite side over the adjacent side. This is the opposite side of the triangle. This is the adjacent side. This is the hypotenuse. So it's going to be the y direction over the x direction. And since we want to find the angle theta, we're going to isolate for theta. So theta is inverse tan. We're just going to write y over x because we know what our values are. So theta is now, I already have it done in the calculator. If you want to look quickly, zoom in, this is the work here, which it rounds to 54 degrees. So we know theta is now 54 degrees. And so our final, because we went west first and then we went south, our final direction is going to be west, 54 degrees south, which would also be equal to south, and 6 is 60, and we're about to 90, so 36 degrees west. Same values. I always like working with this one here. So now that we have our average displacement and our average and our direction, we also have our time. Now we're going to solve for average velocity, which is velocity average is equal to displacement divided by time. Make sure it's average, which now we're just going to plug it in. 6. We're going to round this a little bit because it won't make that big of a difference. 62244.6. Right, because if this rounds up to 3, but 3 rounds down. So we're just going to leave it at 6 meters divided by 120 seconds. So watch the units very carefully. Don't forget to add in your direction. West 54 degrees south. So you want to divide, and my answer was 518.7. 518.7. Don't forget meters a second. And then add your direction. West 54 degrees south. So we want to use sig figs, and sig figs in this question, it was only to 2 units. And to add more information to sig figs, scientific notation does not count. So we're going to use scientific notation. This rounds to 520. So we're going to write 5.2 times 10 to the power of 2, which is rounds to 520 meters per second. West 54 degrees south. So this is your final answer. You can obviously include a therefore statement, which I'm just going to write in now. Therefore, the jet had average velocity of 5.2 times 10 to the power 2 meters per second west, 54 degrees south. I hope that's enough for you. Let me know if you need me to do anything else. That's it. Thank you.